Hello everyone, today our topic is laws of motion, and first 2 to 3 videos will be for board level, and gradually we will move forward to NEET and JEE. Let's start. So our first topic is inertia. So inertia is the property of the material by virtue of which it stays in a rest, or it starts moving, or it changes direction. That is known as inertia. So inertia is the property of the object. It is the inherent property. So that means you can change it only if you apply external force on it. So that is our inertia of rest, inertia of motion, and inertia of direction. See, if a particular object is moving in a straight line, until and unless you have given some external force, it will not change its direction. So it is known as inertia of direction. The inertia of motion, if an object is moving with uniform velocity in a straight line, and if you don't break the object, or if you don't apply a opposing force to that object, the object will move forward. That is known as inertia of motion. Now inertia of rest, see, if an object is staying somewhere in a position, at rest position, if you don't apply external force, it will not move from its position, initial position. Now momentum is simple, it's mass into velocity. As our velocity is a vector quantity, so momentum would be vector quantity. It is represented by p vector. Now SI unit is kg meter per second. Now see, velocity, unit of velocity is meter per second, and mass is kg, so it would be kg meter per second. Now from the momentum we can draw 3 graphs. So usually we have 3 cases. Now case 1 is if velocity of one object is greater than another object, and if we keep the mass of the 2 objects same in the first case. So what would be the first momentum? P1 would be m into V1 and P2 would be m into V2. Divide P1 by P2, mass and mass will cancel out, you will get V1 by V2. Now see, we have assumed that V1 is greater than V2. If V1 is greater than V2, that means this is greater than 1, this is greater than 1. That means P1 is greater than P2. Now from here you can see that this is the equation of y equals to mx. This is the equation of y equals to mx, where y is P1 and x is your V1. So it's the equation passing through origin. So let us say in the first case we have drawn the graph between momentum and velocity. Momentum and velocity. Velocity is in the x-axis, momentum is in the y-axis. It's the equation of straight line passing through origin. You can see here slope is your m, mass is your slope, and mass is constant here. In the straight line you can see slope is constant. Slope is constant. Now in the case 2 we have assumed that mass of object 1 is greater than mass of object 2, and we kept the velocity of the both objects same. So P1 would be m1v, P2 would be m2v. Divide P1 by P2, you will get m1 by m2. As m1 is greater than m2, we will get P1 is greater than P2. P1 is greater than P2. Here the graph is B. See, here in this case also it is y equals to mx. So P equals to m into v. Here mass is variable and velocity is constant. So in this case you see y equals to m into x. So here x is your m, slope is your velocity, and y, in y-axis we will draw momentum. So momentum versus mass curve. In case 2 it is momentum versus mass curve, and you can see it is also y equals to mx curve. So y equals to mx, and your slope is v. Slope is v, which is constant. From the graph you can see velocity is constant. Now move forward to case number 3. In this case we have assumed that momentum of the both objects are same, but mass is variable, and velocity is variable. So as momentum is constant, So momentum of the first object would be mass into velocity. Momentum of the second object would be mass into velocity. So V2 by V1 would be m1 by m2. V2 by V1 would be m1 by m2. We have assumed that m1, mass of the object 1, is greater than m2. If m1 is greater than m2, then we can say m1 is greater than m2, we can say V2 is greater than V1. That means from this equation we can say velocity is inversely proportional to mass. From this equation we can say velocity is inversely proportional to mass. So from this we can say velocity into mass is constant. Velocity into mass constant. And if we consider this, or if we equate this with x y equals to constant, x y equals to constant, we know this represents rectangular hyperbola. Rectangular hyperbola. The graph would be something like this. This is your rectangular hyperbola. So we have drawn in the positive x and y axis this part, but this is a rectangular hyperbola. You can see this is x into y equals to constant, considers rectangular hyperbola. So v into m would be constant, where v into m represents rectangular hyperbola. So graph would be something like this. So this is your rectangular hyperbola, and we have drawn the graph between velocity and mass, and so momentum would be constant. Now we are moving forward to Newton's law of motion, where we know we have already learnt it in 9-10 level. It consists of first law, second law and third law. First law is related to inertia of motion and inertia of rest, and second law is related to momentum, rate of change of momentum, and third law is equal and opposite force. So moving forward to the first law, it states that if you don't apply for a rest object, if you don't apply external force, the rest body will keep in at rest. If you don't apply for a moving object, if you don't apply a opposing force, the object will move forward. So inertia of rest and inertia of motion is the example of first law, and the definition is as I have told. Now what is the example of first law? Now see, example we can see in the section, we will see in the next section that this section is based on inertia of rest, and the next section we will see inertia of motion based on first law of Newton's first law of motion. See, we have already applied this thing in our home, that if there is a, let us say there is a carpet and there are dust. See, the carpet and the dust, both of them remains rest in this position. If we apply external force here with some stick, the carpet will move down and up. But the dust will remain at its position. Why? Because it is for momentum, inertia of rest. Due to inertia of rest, the dust will keep its position at rest, but the carpet will move up and down. That's why we can see that the dust is coming out. Actually, dust don't come out. Dust rest. The dust keeps its position. The carpet moves ups and down, and this is the best example for inertia of rest. You can see there are other examples I have written down. Coin falls into the tumbler when the card is suddenly jarred. When you shake the branch of the tree, its fruit and dry leaves fall down. Now why fruits and dry leaves fall down? See, when the tree branches, these dry leaves and fruits keeps attached at rest, when both of them are at rest, but you are applying an external force, that means these fruits and dry leaves will try to keep its inertia of rest. That means they want to stay where they are, but the tree moves here and there if you apply external force. So that's why fruits and dry leaves fell down. In the next slide we will learn about inertia. Okay, let us continue. There is the example. These are the examples based on inertia of motion. See, we already gained this experience that when a person sitting or when a person getting out of a moving bus or train falls in the forward direction. Why he or she falls in the forward direction? Because his feet or his or her feet is in touch with the moving bus or the surface of the bus. So when the bus is running but that person wants to jump out of the bus, then it is seen that his leg wants to keep that motion, but his body is in rest. So that's why his body is in wants to continue that motion, but his feet, as it touches the ground, wants rest. That's why the person moves forward and falls down. All these are the examples of inertia of motion. Kindly read through this. And if we talk about based on inertia of direction, then is the best example. When a dog chases a hare, the hare runs along zigzag path. Why it runs along zigzag path? Because see, dog has bigger mass. If the dog has bigger mass, then it should have bigger inertia of direction. It has bigger inertia of direction. That's why the dog finds difficult to find the hare. That's why the hare move along zigzag path. Now Newton's second law of motion, we know this already, that rate of change of momentum, that is dp by dt, is actually your force. Now we know P is mv, so mass is constant, keep out from derivative, so m into dv by dt. Now we already know dv by dt is acceleration, velocity per unit time is acceleration, so we got mass into acceleration. This is not our definition. Our definition is force is actually rate of change of momentum. From here we got force equals to mass into acceleration. Now it has three types of unit: absolute unit, gravitational unit, two types of unit actually. So absolute unit is in Newton. 1 Newton is 1 kg meter per second square, because acceleration has the unit meter per second square. Mass has kg, so 1 kg per meter second square in SI. In CGS is 1 dyne, force of unit of force is 1 dyne, so 1 gram centimeter per second square. In gravitational unit, 1 Newton is equals to 1 kg weight or 1 kilogram force. 1 kg weight or 1 kilogram force, that is equals to 9.8 Newton. That means how we can apply this definition? The definition is, if you apply for 1 kg of mass 9.8 meter per second square acceleration for 1 kg of mass, it will put 9.8 Newton on that object. So this is the unit of gravitational unit, that is 1 kg weight or 1 kilogram force. In CGS, this is gram weight or 1 gram force. This is 980 dyne. Remember this relation, 1 Newton equals to 10 to the power 5 dyne. Now if we want to find the second law in component form, in vector classes we already know that any vector can be resolved into three components, that is in x direction, in y direction and z direction. X direction, y direction and z direction. Unit vector along x is I cap, unit vector along y is j cap, unit vector along z is k cap. So it will have fx, it will have fy and it will have fz. So we can write any force in 3D as fx, that is magnitude multiplied by direction. What is the direction along x axis? This is I cap. Now fy into j cap plus fz into k cap. In the similar manner, momentum can be written as px into I cap, py into j cap, pz into k cap. In the similar manner, acceleration can be written as ax I cap, ay j cap, az k cap. So what is force? Force is rate of change of momentum. That means in the x axis the force would be fx, and that would be dpx by dt. Now px is our mass into acceleration along x axis, so m into x. Fy would be m into ay, fz would be m into az. Now based on these relations, we will solve two questions, question number 1, question 2. So let us see the solution of the first question. The question is, forces of 5√2 Newton and 6√2 Newton are acting on a body of mass 1000 kg at an angle of 60 degree to each other. Find acceleration, displacement, velocity after 10 seconds. See, if this is an object, you are applying a force F1 and a F2 on this object at an angle 60 degree to each other. So that means here we have to apply parallelogram law of addition or triangle law of addition. From that law we know the resultant force would be on this object would be root under of f1 square plus f2 square plus 2f1 f2 cos theta. Angle is 60 degree, f1 is 5 root 2, f2 is 6 root 2. Put the values, calculate the square root, you will get 13.49 Newton. Now force is equals to mass into acceleration, so acceleration would be force by mass. Now you have calculated force, mass we know it is given 1000 kg, divide, you will get this 0.01349 meter per second square. Now velocity equation of motion, from equation of motion we can say that v equals to u plus at, as no initial velocity is given, so initial velocity is 0 plus acceleration we have just calculated, acceleration into time is given as 10 seconds, multiply, you will get the answer. S is equal to displacement S, second kinematics equation, S is equals to ut plus half at square, u is 0 here, initial velocity 0, half a t square, you will get the answer. See the second question. A body of mass m moves along x-axis such that its position coordinate at any instant is this. Now its displacement vector is given. Its displacement is given with respect to time. Now see, we know from differential equation we know velocity is actually displacement by time, which is dx by dt. So if you derive this thing, a t to the power 4 minus b t cube plus ct. Now we know ddx of x to the power n, the formula is n into x to the power n minus 1. So here t to the power 4, acceleration a is constant, so keep outside. T to the power 4, consider this as t to the power 4, so it would be 4 into t to the power 4 minus 1, minus b is constant, keep outside. Now this would be 3 into t to the power 3 minus 1, plus dx by dx is your 1, so dt by dt is your 1, c is there, so it will be c. See, after calculation you will get this. Now acceleration we know as dv by dt, and v is your dx by dt, so ultimately we will get ddt of dx by dt. Now what is this representation? This is d2x by dt square. That means you have to derive this thing again. Derive this thing, you will get acceleration, something like this. Now you have to find the force. Force is mass into acceleration, so mass, acceleration is this, you will get the answer. So let us move forward to our next topic, which is impulse. See, impulse is something that when you apply a large force for a short period of time. Let us say you are catching a ball, so large force, the ball is coming with a great force for a small time. When you jump on a hard floor, so your mass, that is your weight, the touching of the floor and your weight, there is a small time interval. Blow of a hammer on a nail, so it's a very small time, so you are applying large force for a small interval of time, that is known as impulse. Impulse is represented by J, and impulse is average force multiplied by time. Its SI unit is kg meter per second. Now what is impulse momentum theorem? See, we know F is rate of change of momentum, so dt, F into dt we can say dp. Now integrate both sides, as it is the time component, so we can say this is 0 to t, and here is it is momentum, so initial momentum is p1, final momentum is p2. Integration of dx is x, so apply, it is upper limit, this is lower limit, so upper limit minus lower limit, p2 minus p1. So what we got, integration 0 to t, f dt is actually this f dt. What is f dt? F dt is actually your impulse. So impulse equals to change in momentum. This is known as J equals to P2 minus P1. This is known as impulse momentum theorem. Now when we can find out impulse in from graphical method also. If you know the graph between force and time, let us say here we have applied a constant force. The area under the graph, that is length into breadth, that is P into F, is your impulse. So for a constant force, area under the force time graph is your impulse. Now if the force is variable, see here in this graph we can see that the force is variable. So how to find out in a variable force time graph? Just simply do the integration, because integration is sum of all the rectangles from T1 to T2. So J is integration 0 to T f dt, that is area under ft graph. Both of them are actually same. Here we have constant force, so simply we can multiply f into t to find out the impulse, but here force is variable, that's why we have to apply integration. Let us move forward to our next topic. See, let us solve a problem related to momentum. A ball moving with a momentum of 5 kg meter per second strike against a wall at an angle of 45 degree and is reflected at the same angle. Calculate the change in momentum. See here, given that a ball is coming in this direction at an angle of 45 degree in the horizontal. Now it gets reflected from the wall with the same angle. It is given in the same angle, it is reflected. The ball is coming in this direction and going in this direction. Now see here, the most important thing is to resolve the component. To resolve the component is the most important thing here. See, ball is coming in this direction, that means momentum. The ball has some momentum, because momentum is mass into velocity. So if it has some velocity, it should have some momentum here. So momentum is in this direction. That means, see, we have two components related to the angle 45 degree. One is P cos 45. The side which is attached to the 45 degree angle is your cos, and perpendicular component is your sine. So let us first consider this angle. If this is 45 degree and the value of this is P, then this direction, this is coming in this direction, so cos 45, the direction of P cos 45 would be in this direction, in the negative x axis, and momentum is in this direction, so that means the perpendicular component, that is sine component, is downwards. Now again see that ball is reflected back with an angle 45 degree, that means the component attached to this P, this angle, would be P cos 45, and that is in the negative x axis, that is in the negative, because the ball is going away, that means it is in the negative x axis. And for this is in the positive x axis, this is P cos 45, and for this momentum, this is in the negative x axis, P cos 45. And what will be the perpendicular component? Perpendicular component will be P sin 45 degree. Now in the 2D problem, we have to resolve perpendicular component and horizontal component individually. So that means we have two horizontal component of momentum, P cos 45, P cos 45, and we have two component of momentum in the perpendicular direction or in the vertical motion. So change in momentum along vertical direction, that is final momentum minus initial momentum. See here that P sin 45 and this P sin 45 directions are same. So that means P sin 45 final momentum minus initial momentum, if you calculate, it would be 0. P sin 45 minus P sin 45 is 0. So that means in the vertical component there is no momentum. So let us calculate in the horizontal direction. So in the horizontal direction, apply the same formula. Change in momentum is final momentum minus initial momentum. Now what is the final momentum? Final momentum you have to take for this thing, for this P. So for this P, the component is P cos 45 in the negative x axis, in the negative x axis. So it would be minus P cos 45 because it is in the negative x axis, minus initial momentum. What is the initial momentum of this P component? Is P cos 45 in the positive x axis. That's why it is minus, this minus is this minus, and plus P cos 45. Ultimately we got minus 2 P cos 45, cos 45 is 1 by root 2, P is given as P is given as 5 kg meter per second and here is 2. So to this calculate, you will get minus 7.07 kg meter per second. Now what is this minus signifies? Minus signifies that ultimately the reaction is away from the wall. The reaction is away from the wall. Shows that direction of change in momentum. Direction of change in momentum is away from the wall. That is the minus symbol signifies. Now let us come to the Newton's third law of motion. Action and reaction is equal and opposite. We already know that. But always remember, action and reaction does not apply on the same surface. Action and reaction applies on the different bodies. Action and reaction applies on the different bodies, because if you are pushing this board, then you need a board to apply. So action and board will give reaction. So that means action and reaction applies on the two different bodies, that is my hand and this board. So you need two different bodies to act on Newton's third law of motion for action and reaction. Applicable, this Newton's third law of motion is applicable irrespective of the nature of the forces. That means the force can be anything. That can be electrical force, that can be gravitational force, that can be mechanical force, or any force, you name it, you can apply third law of motion. See, this object is applying force in this body, object A. So object A will give a reaction force. So the force would be in this direction, FBA. Now A object applies force B in this direction. So B, the reaction of B would be in the opposite direction, FAB. So we can say that FAB, these two things are magnitudically equal, but their directions are opposite. That's why here is a negative sign. Force are same, but their directions are opposite. Now see, let us see an example. If we have a block here on the surface, then its weight is towards through the center of gravity or center of mass, that is weight W equals to mg. Now this is the action. This is the action the block is giving on the surface. So what would be the reaction? It should have some reaction. So this reaction is R. Let us say this reaction is R. So we can say R is W. R is W. For more applicability, you can say it is minus because the direction is opposite. But when we will solve Newton's law of motion related problem, we will omit this minus. We will simply say that R is equals to W. Now let us move forward the next topic. See, let us see the apparent weight of a man in an elevator. So when we will see some elevator related problems, we need to learn the concepts in the elevator. There are actually 4 cases that may arise. The first case is the elevator is moving upward. See, just imagine you are standing on the elevator is moving upward. That means you are connected with the surface, and that surface, your weight is always through the center of gravity and it is always downward, mg. That is your force, W equals to mg, which is acting downward. Now if you are applying a force on this surface, on the surface of the lift, then the surface will apply a equal and opposite reaction force. Let us say that reaction force is R. Now see, this lift is moving upward with the acceleration A. Now here in this problem we have to apply, see, net force. What is the net force? What is the net force along y-axis? What is the net force along y-axis or in the vertical direction? What is the net force? As the lift is moving upward, this reaction force will be larger than this weight. So R minus mg would be your net force. That should be equals to mass into acceleration. So R would be, take m common, g plus a. Now in the second case, the lift is moving downward with acceleration a. So as it is moving downward, your weight would be larger than your reaction force. Then mg, which is acting downward, reaction force is acting upward. So mg minus R is your net force. Now what is the force? force is mass into acceleration. So here in this case reaction force would be m into g minus a. Now here in this case, this is the case of let us say the lift may be at rest or the lift is moving with uniform velocity. If the lift is moving with uniform velocity, that means acceleration should be 0. If the acceleration is 0, so let us say your r is mg is acting downward and your r is acting upward. So that means r minus mg, which is the resultant force, that should be equals to mass into acceleration. What is the acceleration? Acceleration is 0. So this is 0. So that means r equals to mg. That means when the lift is stationary or the lift is moving upward or downward with uniform velocity, in that case your reaction force is equals to your weight, that is mg. Now we have last case, when the lift falls freely. If the lift is falling freely, in that case acceleration should be equals to acceleration due to gravity, that is a equals to g. Now apply this falling freely, so apply this thing, r equals to m into g minus a. Here acceleration is equals to g, so g minus g, which is 0. That means your reaction force is 0. As the reaction force is 0, you will attach to the top of the wall, top of the lift. You will attach to the top of the lift because here reaction force is 0. That's all for today. In the next part we will start from conservation of linear momentum.